In 1969, Dr. Donald Goodwin gathered group study participants and asked them to each recall the object he shown them 2 minutes prior. The twist? All the participants were very intoxicated. Despite this, most could pay attention to the task and correctly name the toy they had just seen. Yet, when Donald asked them to recall the object a mere 30 minutes later, half of the participants drew a blank, having blacked out the earlier moment entirely. This study illustrates a strange and somewhat selective effect alcohol has on the brain. Many intoxicated people can perform complex tasks, like holding detailed conversations or navigating walk home. Yet, for those experiencing what is known as a blackout, the memory of these events is quickly forgotten. So how does alcohol cause these memory lapses? First, let's identify the culprit. While a single drink often contains hundreds of different chemical compounds, ethanol is responsible for alcohol's effect on brain. Ethanol is a lightweight alcoholic, meaning its structure easily dissolves into fats like those in the membrane of the outer-brain barrier. Once into the brain, ethanol's unique structure allows it to bind to, interact, affect many different neural receptors, impairing pathways that allow you to make careful decisions, control your impulses, even manage your motor skills, and networks that control your memory seem to be especially sensitive to alcohol's effects. Typically, information about your surroundings is taken in by your sensory organs and centered brain. Neurons transfer this information to one another via a chemical messenger called neurotransmitters, which are released by one neuron and received by receptor at another. When neurotransmitter bind to a receptor, it unlocks an internal channel, allowing small ion to flow into the cell. If enough ion enters the cell, the neuron fires, sending the signal forward. Through this process, different regions of the brain can communicate with one another in milliseconds, creating a moment-to-moment understanding of the world. But ethanol interacts with the receptors, making it harder for neurons to communicate. While compromised, the brain is still able to transfer information, which is why many intoxicated people seem somewhat capable of performing basic tasks. In other words, brain function is highly impaired, but not completely broken. But memory storage is a different story. The transfer of moment-to-moment understanding to something we can remember is thought to depend on the process called long-term potentiation, or LTP. LTP happens throughout the brain, but it's especially important in learning of memory regions like a neocortex hippocampus. During LTP, the firing of the neuron triggers physical changes to its structure. For example, more receptors may be moved to the cell surface, making the neuron more sensitive to future signaling from its neighbors. These physical changes increase the likelihood that the cell will fire again at the connection, strengthening the wiring between neurons. And through this stronger connection, it's thought that a stable memory is formed. Yet studies suggest that ethanol has a unique ability to disrupt the LTP, blocking the physical changes needed for memory formation. So while moment-to-moment information is encoded and understood, the storage of the information is blunted, resulting in blackout. Of course, not all levels of drinking result in blackout. They happen when the concentration of alcohol in the blood, or BAC, exceeds a certain level, approximately 0.16. But there's no magic number. A slightly lower BAC, brownout, or spotty memory of events can occur, as some neurons continue to function properly while others fail. And drinking too much can cause a person to pass out altogether. Other factors like dehydration level, genetic differences, medications, even how to be eaten can affect the likelihood of the blackout. And teenagers appear to be especially vulnerable due to substantial change in the brain development during those years. Alcohol's short-term effects usually don't last longer than the time it takes for the body to metabolize it, or about a day. but repeatedly overdrinking can damage the neurons and permanently impair memory. It can also harm other organs, like the liver, which works overtime breaking down alcohol. After all, experiencing a blackout or witnessing others in this compromised state can be a lot for your mind and body to process.